Okay, yesterday we learned that when we have a number, let's call it 3,451 and 3/10, and we multiply that by 10, what happens to our number?
There's 2 zeros, so you move the 3 down by 2. No, 1.
Yeah, if we multiply by 10, we have 1 0, so we just go over 1, right? So every single number moves. And that answer would become 34,513. If I had 27 times 1,000, how many places to the left would I need to move my number? 3 places to the left, because I have 3 zeros in 1,000, so I would go 1, 2, 3. And then do I just leave it like that? What do I need to do? Exactly. You can't just leave a number that says 27,000 unless you have the zeros to go with it. Zeros have no value. They act as a place marker. When I divide, I do the opposite. $15 divided by 10. Okay, you move the 5 to the right 1 place. And move the 1 to the right 1 place. So 15 divided by 10 equals 1 5/10. You would do the same for hundreds, thousands, so on.
Will we ever do this, like, instead of using like 100, will we ever go to like 2 or 3 hundreds?
Eventually we'll get to that, yep. Okay, take a look at this. We have the number 54,000. Times 10. Yesterday you were taught if you take the number and you place it in the place value chart, you move it over 1, right? Is there an easier way to do this that wouldn't require a place value chart? What do you think? Add one more zero to the end? So if I were to use a place value chart, I would move this like this, right? 1 over. And that equals 540,000. Would I have arrived at the same answer had I just added a 0 onto my original problem? Yes. So if I were to take whoops, sorry about that. 54,000 divided by 10. How do you think I would do that?
You take away the 0.
Okay, you take away a 0, but what if I had just a whole number? Could I take the whole number away? What could I do? Let me show you guys a trick. It's all about this thing right there. Decimal. The decimal is kind of like the equator around the earth. You can't see it, but it's always there, right? So if I have any number, there's always something imaginary at the end of that number. What's always there? You don't see it, but it's always there.
Zeros?
Well, What would you put before the zeros?
Decimal.
Decimal. So you always have this imaginary decimal right here. And when we multiplied, our number got bigger, right? When we divide, it gets smaller. So if I were to multiply 56 times 10, how many places over would I move the decimal? You'd move it one place over, right? Can I just leave a blank? What do you think goes inside that half circle? No? What do you think? A zero. If that gets confusing with the decimal, all I would say to do, anytime you multiply by 10, you add a 0. You multiply by 100, you add 2 zeros. You multiply by 1,000, you add 3 zeros. But you can't really do that when you have a decimal. So let's look at our 5 6/10 again. And we're going to divide it by 100. The 2 zeros tell me I need to move my decimal 2 places. And the number's going to get smaller, right? So what direction am I going to move my decimal to make my number smaller? To the left? And I'm going to move it 2 places. So I go 1 place. Am I still good with that? I have a number there, don't I? And then I go another place. I just made a half zero and a half zero, which equals 100, right? So I went 2 places. Can I just leave it like that, hanging out in the middle of nowhere? What do I need to do? Put a 0 before the 5. So now we know that 5 6/10 divided by 100 equals 56. What place is that? Thousandths. Let's try one more. Another trick you could do is take your 1,000 and take your eraser. Check that out. Isn't that cool? So now you know exactly what that side should look like. Where's my decimal? Where's my decimal? Where's my decimal? Anyone know?
Decimal is in the between. Right there at the end.
Okay, it's right at the end. And by the time when I'm done, it needs to look like that, right? So I'm going to take my imaginary decimal and go boom, boom, boom. Does it look like that? Yes, there's 3 half circles. So the answer would be 152 thousandths.